Hello everybody, my name is Khaled Siddiqui, and in this video I'm going to teach you about smart USB chargers. What is a smart USB charger? Why do you need it? Why is it important to have one? And what are the benefits, pros and cons and all that? So a smart USB charger is a USB charger that tells you exactly the voltage and current of each port that is used to charge a device. Why would you even worry about knowing the current and the voltage? Each electronic device, I don't care if it's a phone, if it's an Apple Watch, or if it's a GPS, whatever it is, they have lithium ion or nickel cadmium batteries, and these batteries they have a certain amount of life cycle, and as the battery gets weaker and older, the current drain will be lower. Basically, it doesn't draw enough current to charge itself as the battery gets weaker, and what happens is that the life of that battery will be shorter, and it will be unreliable. Now, this could be very important for something that, let's say you're using a GoPro or a DJI Pocket or something like that, in which the battery life is extremely critical. You could lose important footage because you are relying on a defective battery that wasn't holding a full charge. When your battery shows 100% charge, it doesn't mean that the capacity is still 100%. If the capacity of the battery drops to 80%, when it says 100% charge, it means 100% of the remaining 80% that is still holding a charge. As the current as the battery capacity drops, the current that it draws to charge itself also drops, and that's how you can tell. This is why having a smart charger is really handy, because it gives you real-time live monitoring of your battery status on each electronic device that you're charging off of the USB port. Okay, so now let's see and find out what this is. So this is an example. I'm not being paid by the manufacturer of this smart charger. This is just an example. You could buy any make, any model, any brand. As long as it's a smart charger, you should be good to go. So let me show you how this is. So basically what this is, it's a power supply, USB power supply charger with 8 ports. So this is 1, 2, 3, 4, 5, 6, 7, 8. And this is the power intake. So you apply power here and you have 8 ports. And the screen tells you how much power is being drawn from each port. And based on that power drainage, you can tell if all the devices are performing at their peak performance or they're not performing at their peak performance. Okay, so now what I'm going to do is I'm going to plug this in and show you how we can tell. So now it's plugged in. Notice it's 5.1 volt and the wattage is 0. 0 watt means that none of these ports are using any of the electricity or any of the power. So now the first thing I'm going to plug in is an Apple Watch charger. Watch, the Apple Watch charger is actually a oscillating circuit, because this is DC. The electricity that comes out of this is DC. Inside this is the IC chip that changes that to AC, alternating current. So even if the Apple Watch is not plugged in or it's not attached onto the base, it will still draw some current. So let's find out. Okay, so the Apple Watch charger draws current so insignificant that it's not even noticeable here in terms of amperes, because this is amperes, so it's not milliampere. Remember that. So it's so insignificant that it doesn't even show. Now I'm going to put the watch in. Let's see. Okay, as I put the watch, as you can see, with the watch attached to that base, we are only, well, let me get this to an angle so you can see better. We are only basically draining and a very insignificant amount of power, which is 38 ampere, that is 380 milliamperes. Okay, so the Apple Watch is really not draining that much power. And when you remove the watch, it's basically down to nothing. It's down to nothing. Now let me do an experiment. I'm gonna, because that's electronic, I'm going to do an experiment by putting a metallic object on that Apple Watch, like a little speaker here, and see if that will change the current. And yes, it does. Any metallic object will cause current flow, as you can see. This was just a little speaker. Okay, so that's why make sure that your Apple Watch charger is not facing down on a metallic table, because it will simply ruin the Apple Watch charger. It will wirelessly short circuit it, because this is a magnetic inductor, which inducts AC current in the air at higher frequencies, that it will change to DC once it goes to the coil inside the Apple Watch. Okay, now let's check our GPS unit. Okay, so let's get this GPS unit. I'm going to plug this in. Okay, so that's port number 2. This was Apple Watch. Port number 2 is my GPS unit. Let me put this in a little angle so you can see better. Hold on, because from this angle you don't really see very well. I'm gonna put this little thing underneath there, so now you can see better. Okay, so now I'm gonna plug this in, and let's see the health of the battery on this GPS depending on how much current it draws. Okay. Okay, so the GPS is currently drawing 0.49, which is 490 milliamperes, which is good. The battery is not in its top-notch shape, because it should be 500 plus milliamperes, but even at 4 point something, it's good. If you turn it off, let me turn this off and see how much it charges when it's off. Wait a second. Turn this thing off. It doesn't want to turn off. Actually, this is the wrong cable, because this is the sync cable. I should use the cable that prevents it from going into sync mode, which is this cable. Okay, so now it shouldn't go into sync mode with this cable. Let's see. Let's increase the screen brightness and see how much current change it is. So right now, as you can see, it's 0.4 at low brightness and 0.5 at the 0.43 or 0.5 at the highest brightness. So that's because it has a battery, so it's not only using this power, it's using the battery power as well. So that's why it's the battery is fully charged. Basically, the battery on this is fully charged. It's not accepting any additional charge. So that's that. Now I'm going to unplug this, turn this off, and let's plug in my iPhone, and let's see what kind of current I get on the iPhone. Okay, so this is for the iPhone, which is in port number 3. Okay, there it is. Now let's plug in the iPhone. Okay, so let's look at the current draw there. Okay. Now notice the iPhone draws the highest amount of current. Notice this right here. It's 1 point something. So now 1.5. See, it's going up and down. It's basically like fluctuating. The current is fluctuating. It's right now it's at 1.3. And if I turn on the iPhone, this should go up. Let's see. Okay, so the iPhone is on, and look, the current draw increased to 1.4, 1.3. If I play a video, I'm sure it goes even higher because it draws more current. So let's now put the watch at the same time. So now we have the watch attached. This is the watch at 0.34 amp. That's 350 milliamperes. 340, and the GPS. So now I have all three devices, the GPS, and you could see all three devices, and this is the total wattage. Right here you see the total wattage is 11 watts. So I'm way below my maximum limit on this, because this is, you know, pretty powerful. Let's see what's the wattage on this. Okay, so 12 times 5, it's 60 watts. This is 60 watt. Volt times current gives you the wattage. So this is 60 watts, and I'm only at 8 watts right now. I have plenty of, plenty of additional load capacity on this that I can add if I wanted to. But this gives you an idea. It gives me the health of the battery on each device, tells me that this is, the battery is good, it's holding, draining electricity. The battery on the GPS is okay, it's draining electricity. The GPS battery is not in its greatest shape, because it should draw more than that. Same thing with the phone. Now I'm going to turn off this. I turned that off. I'm going to turn the phone off to see the current change. So now when the GPS is off, whatever current you're seeing here is solely for charging the battery. Since the battery wasn't fully discharged, it's the battery was literally full already. That's why the current flow is minimal amount. Okay, so this is something that I thought I should tell you guys. This way all your electronic devices that require USB power are in top-notch shape, and that you're not basically being caught and surprised by taking your camera or your GPS unit and find out that the battery, even though it said 100%, it wasn't actually 100%, because the battery was losing its power. So make a note of the current flow. If you get this device, and make sure that you make a note of the current flow, how much current should the device draw when it's new. And as the battery gets older and older, the current flow drops. It gets to the point that the battery doesn't draw any current, and that's when you know that it's time to replace the battery for sure. But you should replace the battery even if the current flow drops in half. That's bad. That's really bad. You shouldn't rely on that battery and that device anymore. Okay, I appreciate your time. Thank you for watching. Please make sure to like and subscribe.